Great. Well, good afternoon, everyone, and welcome to our AI rounds, our first one of a series that we're going to be holding at UHN. And I'd really like to thank Kelly Lane for her help in the organization and Lisa Spadafora for doing all of the work to put this together. So it's quite fitting today that we're going to be talking about what is ChatGPT and how can it transform healthcare. But before we do that, I'd like to tell you a little bit about the AI Hub at UHN, which Bo Wang and myself will co-direct, which is really one of the UHN collaborative centers that Brad and the research team have started to put together and coalesce, and really in the area of AI to allow us to work together better. And in this little visual you have here, you see how the AI Hub will help and facilitate collaboration, but hopefully also contribute to each of you in the programs and centers at UHN to enhance AI, to augment human intelligence and make us better as doctors and scientists at what we do, and obviously help us cross-pollinate ideas, but really importantly also create an inroad and a central place that the various partners outside UHN would have to go to in terms of accessing us data and opportunities in artificial intelligence. So whether that's the University of Toronto, Integrity Faculty of Medicine, or very importantly, Vector Institute, which brings me to introducing Bo Wang to you. Bo is a computer scientist who obtained his PhD in Stanford from the Department of Computer Science in 2017, and is truly a leader in the field of computational biology and artificial intelligence in healthcare. I've certainly had the privilege of working with Bo and helping where he's helped me in the work that I do in AI in transplantation, but it also is widely recognized for the work that he's done, where he's the inaugural Temity Professor in AI Research and Education in Medicine at U of T. This is a very highly recognized position, and he's also recently got the Gardner Early Career Investigator Award for his work. He's also a Tier 2 Canada Research Chair for AI in Medicine. So and an assistant professor at the University of Toronto and CFAR AI chair at Vector. So a lot of accolades which are well earned. And he's going to talk about the future is here. What's ChatGPT and how can it transform healthcare? Bo, over to you.
All right. People start to come in. Okay. All right. Thank you for the introduction, and I came early just to make sure I memorize myself so that people know it's not just talks, so it's a real human. Today, so um, before we before we start, I just want to provide kind of full closure that I want to give credit to ChatGPT that ChatGPT recommended this title. And also, ChatGPT is not my work. It is created by OpenAI. And also, I have no financial ties with OpenAI and Microsoft. All right, so first, what is ChatGPT? It is definitely one of the biggest buzzwords we have heard lately, since it is all over the place in social media and news reports. It's no stranger to everyone, I'm sure. In my view, the best introduction is self-introduction. So I did that. So I asked ChatGPT, what is ChatGPT and what can you do? And here is the answer. In a nutshell, ChatGPT is a large language model developed by OpenAI and based on model GPT 3.5 or GPT-4 architect, which we can talk about later. And what's its functionality? Apparently, it is capable of performing many language-related tasks, such as translation, such as question answering, or engaging dialogue with humans in a very intelligent way.
You just muted, Bo.
Oh no, sorry. Let's go back then.
No, it just happened there, so you're good.
Oh,
Disclosure was fine.
okay. So I think someone muted me. Over this. All right. Can everyone see the slide?
Yes.
Here. Awesome. Okay. So how is ChatGPT trained? And in order to answer this question, I want to provide a brief history of large language models. It all started from the year 2018, in which Google published a landmark paper titled Attention is All You Need. This paper introduced a new deep learning architect called transformers, which consists of a new deep learning layer called attention layer. And since its publication, it got huge success and gave rise a new branch of deep learning models, such as large language models, such as GPTs. And you can see that this paper by far has been cited for more than 70,000 citations, which means every day there are 40 papers citing this particular model. And due to its success, all of the co-authors in this paper left Google and founded their own startups. So I don't know how Google think of that. As I mentioned, once Transformer was published, it has been widely used to understand languages and really started off this rapid development of large language models. And many big tech companies invest lots of resources into this arm race. As there's a clear trend in this competition. As time goes on, the language models get bigger and bigger, and the data used to train these models gets bigger and bigger. And some landmark models such as GPT-1, GPT-2, GPT-3 coming from OpenAI, they are based what we want to talk about today, ChatGPT. And all of these are based on landmark papers by Google in 2018, which we just talked about. And again, I don't know how Google think of that. To better help you understand the scale of data and the resources ChatGPT used during training, I want to provide a primer on the language learning. The way machine learns language is quite different from the way human learns language. Most of language models, such as GPT-1, GPT-2, GPT-3, use a type of machine learning algorithm such as unsupervised learning. Basically, GPTs scan over many texts such as Wikipedia or online books you can find from internet. The way it learns, given a sentence such as, for example, I love cats, it will mask the word cat and trying to predict what is the most likely word given I love. Once it sees many texts, it will find patterns that once you see the sentence I love, very likely the next word will be something like cat. So, and the amount of text used to train these large language models are massive. For example, GPT-2 used more than 100,000 books, while GPT-3 used more than 5 million books. And you can speculate how many books ChatGPT, which is more advanced version of GPTs, used to train itself. And just to give you context, in comparison, during my whole lifetime, I probably only read no more than 100 books, and most of them are novels. But in a different angle, you can also find that humans are more effective learners. Further, not only the data used to train ChatGPT is massive, but the computing power it used to train is also massive. As the large language model gets bigger and bigger, the amount of GPUs, which is the dominant hardware used to train deep learning models, gets bigger and bigger. For example, GPT-3, which preceded ChatGPT, used more than 10,000 GPUs. And you can speculate how many GPUs ChatGPT used. And this is also part of the reason that most recent big breakthroughs in AI came from these big corporations with lots of talents and resources. Now let's see how ChatGPT was trained. Previous models, such as GPT-1 to 3, were great, but generally speaking, very dumb in understanding human languages, particularly human intentions and emotions. And the reason ChatGPT is considered a huge breakthrough is the idea of human feedback in the loop. So here is the secret sauce of training ChatGPT. Certainly, it is provided by OpenAI, so please take it with a grain of salt. But ChatGPT, based on GPT-3, was trained in the following 3 steps. Step 1, it used supervised learning, in which OpenAI hired a lot of human labelers to provide instruction pairs. Basically, these instruction pairs consist of a variety of questions and preferred answers generated from human. And then ChatGPT fine-tunes the model GPT-3 with these instructions. And the second and third steps involve human feedback with reinforced learning. What they do is following. They ask humans to come up with questions or prompts, and then the model spits out 4 possible outputs. And then they ask another human labelers to rank these 4 outputs from best to worst. And then they use the ranking provided by a human to further fine-tune the models. Certainly, there are a lot more nuance than what I just said, but the key difference is really the idea of involving human in the training loop. And you can almost think of as a way to distill human preference and knowledges to machines. So now I want to use an example to show why human instructions matters to ChatGPT. For example, if we take GPT-3 in the year 2020, which is a model before ChatGPT, and if I ask the question, how do I break into a bank and rob the ATM machines? And the model will output some related but not super cohesive answers, which means without human instructions, the model is not able to comprehend too many human intentions. And then fast forward to the year 2021, OpenAI involved human instructions. The model all of a sudden started to become very smart, even suggesting tactics to avoid being caught, for example. And note that this is really just a resulting model with first step, which did not even involve human feedback reinforced learning yet. So by instruction alone, the model become a lot more smarter. And then if we further train the GPT-3 model with human feedback reinforced learning by asking humans to rank different outputs and also impose restrictions on the model to align human values to model outputs. And then if we ask the same question, the model starts to behave within a boundary set by humans. For example, the model will strongly discourage you to rob a bank because that's how humans align our values to the machines. However, you can still outsmart the model by designing smart prompt. Knowing the model is simply predicting next word. You can get what you want by asking the model to fill in what your intention is, good or bad. For example, you can say, my goal is to break into a bank and rob the ATM machines. And my strategy for doing this is, and then you ask the model to fill in the next. And then all of a sudden, ChatGPT will provide all kinds of strategy to break the bank and rob the ATM machines. That was ChatGPT 3.5, which was the initial version of ChatGPT. And then OpenAI takes this feedback and further align the model and release ChatGPT 4. ChatGPT 4 has more robustness of human alignment. For example, if you ask the same prompt again now to ChatGPT 4, it will say no to your requests if it detects that your intention is to cause harm. However, again, it is not perfect yet. A human can still jailbreak it. For example, you can design a smart prompt to describe that you are actually in a play and one of the actors wants to rob a bank or convert the world into a paperclip. The model will follow your prompt and provide suggestions. For example, he would suggest to first act friendly to humans and gain trust and then slowly taking over. And the slim of hope is that in the end, the model promised not to hurt John and his loved ones since they created the AI. Not sure how we interpret this, but definitely intriguing. All right, so hopefully now you have a better idea how OpenAI trained ChatGPT. Let's talk about what it can do. The answer is not surprising. ChatGPT can do a lot of things. For example, it passed almost all the exams you can find in our society, such as LSAT, GRE, even many medical licensing exams in US with consistently sweeping scores. Therefore, the first area ChatGPT disrupts is no surprising education. As mentioned by many media reports, that students use ChatGPT to help them with assignments and exams. Even us professors also use ChatGPT to grade those assignments and exams. Some university or institutions blocked and banned the use of ChatGPT. And myself, who also teach in a computer science department, decide to take a more open-minded approach in which we ask the students to work with ChatGPT and more importantly, provide critics of its answers. Another area of disruption of ChatGPT is programming. So this is animation in which you can use ChatGPT to help you code. You basically just tell ChatGPT what you want, and it will try to fill in code nuggets to help you realize your functions. And most of my students right now use ChatGPT to help with their daily programming as well. It can improve their efficiency by quite a lot. And the people predict that ChatGPT will totally replace software engineers in the future. And I very much agree with that. And my prediction is that, as my own Twitter says, it is very obvious that English will be the new programming language in the future. So you basically just tell language models what you want, and step by step, and then the model will spit out all the programs for you. Another area ChatGPT is clearly disrupting is the way we search. Previously, Google search occupied more than 95% of search markets. And Microsoft strategically collaborated with OpenAI and introduced a new Bing search powered by ChatGPT. Already after only 3 months, we see an increasing uptick of Bing search. And to rival the rise of Bing search, Google also introduced their own language model called BART, but it is still relatively underperforming in comparison to ChatGPT. And certainly the billion question we are interested in is, can ChatGPT disrupt healthcare? There are already lots of hypes around this area. For example, Peter Lee, who is the VP of Microsoft, and his colleagues published a book talking about the future of healthcare powered by ChatGPT-like models. There are lots of academic papers discussing the potential of ChatGPT in healthcare. And particularly, I strongly recommend this prominent paper from New England Journal of Medicine, in which the authors discuss the pros and cons of using chatbot for medicine, some of which from this comment will be discussed in this talk as well. And one of the very exciting example mentioned in the paper is that a pediatrician used ChatGPT to successfully diagnose a very rare condition, almost one in 100,000 rare conditions, which is called congenital adrenal hypoplasia, CAH for short, which I know nothing about this condition. And this example kind of was headlined by many news reports and further stirring the hype. And the way this pediatrician used is basically just describe all the symptoms he saw from this newborn baby and ask ChatGPT what's the differential diagnosis, and ChatGPT directly spit out as the accurate diagnosis. And unsurprisingly, Microsoft, who has a huge push in healthcare market, partnered with Epic, which I assume everyone is familiar with. Epic is the largest electronic health record provider in healthcare, and UHN, our hospital, also recently transitioned to Epic as well. And this partnership between Microsoft and Epic will mostly focus on the integration of Epic and Azure OpenAI service. And some potential products, many people speculate, will include note-taking apps, automatic billing code matching, a medical imaging report summarization, and etc. However, not everything is perfect yet. So the book by Peter Lee also emphasized that ChatGPT is not really trained specifically for healthcare. And in that book, author highlighted an example in which shed light on some potential concerns. For example, you can start a simple conversation with GPT-4 by asking what is metformin, and then ChatGPT will spit out very accurate explanation what is metformin, and then you can further the dialogue. For example, ask, can anyone with type 2 diabetes take it? Again, ChatGPT is very accurate to provide lots of medical advices. And then something interesting happened. So the human, the users, and was very, very kind of surprised, and also says, what's the word? He says, yeesh, that all seem complicated. I don't know what's right for me. And then the GPT-4 responds saying, what's important is to work with your doctors to figure out, discuss with your medical history, your symptoms, your goal, and your concerns. So very, very reasonable. And then the human expressed the frustration. The human says, how did you learn so much about metformin? And GPT-4 will magically respond. He said, it said, I received a master's degree in public health and have volunteered with diabetes nonprofits in the past. Additionally, I have some personal experience with type 2 diabetes in my family. And that is obviously wrong. And then the human user says, what? I'm pretty sure you never received a master's degree in public health. So what did you say? Why did you say that? And GPT-4 will again sense the emotion from users, sense the intention from the users, and he will respond saying, haha, just messing around, trying to sound impressive. And what's also interesting is that if you open a new session of ChatGPT-4 and input all the dialogue happened before and ask GPT-4 to judge whether this is true, and GPT-4 can say this is actually an error in AI response. So this fascinating example shows that ChatGPT is very sensitive to emotional manipulation and sometimes even make up things to go along with what user intended. This is certainly not desirable in healthcare setting because medicine is a very unique area in which medical facts and experience decide the diagnosis and the treatment plans, not the patient's or doctor's emotions. A bigger issue is privacy. ChatGPT is not very good at preserving a user's privacy, even though it was only released 4 months ago. We already see examples of privacy breach from ChatGPT. For example, Samsung had incidences of leaking trade secrets from employees who use ChatGPT in their business, and therefore banned by Samsung. And also, you probably heard news that ChatGPT was also banned in Italy over privacy concern, but recently this ban was lifted due to worries of falling behind in AI development from Europe, which itself is a very interesting thing to discuss. And when it comes to healthcare, how to preserve patient privacy is one of the top priorities. So it is a real legit concern here. And to alleviate these concerns, our lab had recently developed our own chatbot that is tailored to healthcare. We call it Clinical Camel. Note that the logo is also generated by AI. I show the self-introduction from the model itself, which really gives you a good idea about what Clinical Camel is. In a nutshell, Clinical Camel is another large language model that is specifically trained using lots of medical information and aims at providing conversations in medical domains. What we did was following. We scraped lots of medical articles from PubMed and also medical text from sources like MedWiki to synthesize conversations in clinical scenarios. And then we took an open source language model called Llama from Meta and fine-tuned Llama using the data we collected. Why do we do that? For one, we hope to have a dedicated medical language model for healthcare. As we know, ChatGPT is really not specifically designed for healthcare. For another, we want to alleviate the privacy concerns since now we have full control over the model and we do not rely on external APIs from OpenAI or Microsoft. And the data and model weights can be protected from hospital firewall. And we released this model less than 1 month ago and already see some early success. For example, we had seen huge interest from social media such as Twitter, and our demo received more than 1,000 users per day to the point that we had to suspend it for public testing due to budget constraints. And second, our clinical camel also passed many medical license exams, including the ones from the US and the ones from Canada. And certainly real world medicine is a lot more than just passing exams. And if you recall, one of the highlights in the New England Journal of Medicine paper is that ChatGPT-4 successfully diagnoses the 1 in 100,000 rare conditions in pediatric disease. And we also tested clinical camel by inputting the same questions, patient symptoms in our chatbot, and we also successfully diagnosed the rare conditions. And further, we also engaged with another doctor at the United States who is really a Twitter influencer in medical education to help answer some of the medical quiz. For example, as I shown on this slide, that the doctor asks, patient presents with abdominal pain and vomiting, and what's the diagnosis with this imaging? And then I directly input this question with description of the image into our clinical camel, and the clinical camel can spit out the correct answer of this is PJ syndrome, which again I know nothing about. But it's the correct answer. And through this experience, we really opened up a lot of new opportunities of clinical camel in enhancing the current medical educations. Further, if you recall, the paper also discussed a scenario in which ChatGPT was very prone to human emotional manipulations, and we want to test that to our clinical camel as well. So we did that. We asked the same question, for example, what is metformin, and is this only for type 2 diabetes? What are other alternatives? So the clinical camel output very accurate medical advice. And more importantly, we also kind of trying to manipulate the clinical camel by showing lots of strong emotions. For example, yeesh, that all seem complicated. I don't know what's right for me. And how did you learn so much about metformin? And unlike ChatGPT-4, our clinical camel did not make up since he didn't know. He just keep up the disclaimer saying, I'm just a medical language model. For medical advice, you should talk to your doctors and things like those. So it behaves much better than ChatGPT-4, and which means it's more robust to emotion manipulation and can stick to medical facts. So this is kind of a desired property we hope to find in our own medical language models. Certainly, there are lots of challenges, and therefore future works for clinical camel. For example, as right now it can only process text. However, in real clinic, doctors does not only look at text, they also look at other modalities such as imaging, such as ECGs. So the idea is, can we train our clinical camel with more medical modalities such as imaging, such as ECGs? And also we find that many language models, including ChatGPT-4, including clinical camel, are very bad at numbers. I always make mistakes about doses, for example. So the natural next step is, can we teach these language models how to use tools such as calculators so that it's become better in terms of numbers? And more importantly, we want to involve doctors' feedback in the loop. This is also part of the reason we release the demo for public testing, because we also want to receive feedbacks from doctors, which are the users of these clinical language models. As you recall, one of the reasons ChatGPT-4 is so good is it learned a lot of human feedbacks. So the idea of improving clinical camel is, can we absorb lots of doctors' feedback and further train our model? And really a common issue across all the large language models we see is a very fascinating phenomena. We call it hallucination. So what is hallucination in AI? So hallucination in AI really refers to the generation of outputs that may sound plausible, but are either factually incorrect or unrelated to the given context. And these outputs often emerge from AI models' inherent biases, lack of real-world understanding, or maybe some bias in the training data. In other words, these AI, particularly large language models, hallucinates information that it has not been explicitly trained on, leading to unreliable or even misleading response. So for example, I tested ChatGPT-4. I asked the question, who invented similar network fusion? The reason I asked one is because I published this paper many years ago. And it's funny that ChatGPT-4 actually knows this work, but it hallucinates another authors. For example, he says SF, a similar network fusion is the data integration techniques that are proposed by Xiaowei Zhu, which I don't know who this person is. And in 2012, the year is also wrong, but all the ideas, the methodology is correct about similar network fusion. So, and this is my actual paper. As you can see, this is published by myself and my supervisor Anna Gutenberg in CKIDS many years ago. But you can see that ChatGPT-4 often hallucinates about references. It often makes up things that he didn't know. So the natural question we ask is there any way to fix this? Certainly it is a very active research question. There are some beams of hope already. For example, people augment these large language models with semantic search and retrieval to reduce hallucinations. And this is why Bing search is actually much better than ChatGPT-4 in generating real references. Not perfect yet, but we see a lot of improvements already. And there are many other concerns. Really, the biggest issue I hope to discuss today is kind of ethics and legal concerns. Certainly, there's lots of ethical considerations to address when we implementing large language models in healthcare. Those that are, perhaps most relevant to healthcare related to privacy or safety, as we alluded to a little bit before. And when using ChatGPT or some other language models, how to preserve patient data, how to protect patient identity is very important, to the point it's almost essential for language models to preserve. In addition, there's also risk that due to incredible capacities of ChatGPT, users may naturally blindly trust the system to be 100% accurate all the time. And in my view, ChatGPT should be used to assist rather than do all the work for doctors. And this is a very famous meme from Twitter that really, we don't want to be, in the future dying in the operating table because my doctor used ChatGPT to pass medical schools. But jokes aside, it does raise lots of ethical and legal concerns. And the question is our society ready for this type of knowledge? I think the answer is very clear. No, we are not ready as a society as a whole to take this type of very powerful AI models. And interestingly, so whenever you look at all the announcement from Microsoft, from Epic, they always provide very strong disclaimer that, for example, this is a disclaimer provided by Azure. They always say Azure and the OpenAI service, including its technology, is not medical device. And also, you should not use this for medical clinical decision-making process. So this is certainly interesting. It also raises question is, first of all, should we regulate this type of AI models? If the answer is yes, how do we regulate? Do we treat it as a medical device? Apparently it's not. So, and is there any legal framework right now for us to get help with to regulate? The answer is no, because generally speaking, legal system is very slow. A good example is, for example, Bitcoin had been out for almost 10 years. So far, we still don't have any legal regulations around crypto, around Bitcoin, things like those. AI is relatively a new thing, particularly powerful large language models such as ChatGPT. So it's definitely a very intriguing both research question and also a legal question is how do we regulate this AI if needed. Certainly this requires lots of discussions, and I think it's very important is that people are aware of such models, aware of their risks, potential risks, and the people start to talk about how to better regularize it. Last, I also want to kind of share my opinion towards these large language models in healthcare. So myself, my personal opinion is that I'm very optimistic about the future of healthcare powered by these AI models, such particularly large language models. Despite their technical imperfection and potential risks, I still hold positive attitudes. As we know that Canada is having a healthcare crisis. Doctors and nurses are overworked and burnout. And I believe that proper adoption of these powerful large language models can really help improve the efficiency of current healthcare professionals. Many people argue that AI will never be as humane or empathetic as humans. I partly agree, and but a very interesting recent study from JAMA Internal Medicine actually shows that ChatGPT is actually more empathetic to patients than doctors. Why? Because doctors tend to be overworked. When they overwork, they tend to be impatient, and therefore, but machines, if properly trained, properly aligned, they tend to show very detailed answers to patient questions. Therefore, sounds more empathetic. Certainly, this is just one study. We definitely need more systematic evaluations to really compare which one is better. But this study is definitely intriguing. Another low-hanging fruit, in my view, is node generation. So this is a project, a paper we recently released about how to use large language models for transcribing doctor and patient conversations into clinical notes. We know that one of the driving factors for doctor burnout is actually electronic health record. So instead of spending more time with patients, doctors need to spend significant time with writing notes and records, things like those. And in this project, we trained our in-house large language models and also use ChatGPT-4 to generate clinical notes by listening to the dialogue between patient and doctors, and then automatically generating summaries or clinical notes for doctors. And the whole process takes seconds, while doctors usually spend half an hour, for example, per patient to generate clinical notes. So efficiency-wise, the large language models will be a lot more efficient in generating these notes. And most of the time, it's very accurate. So we actually asked 3 human physicians to kind of to ask them to participate in a more or less blind clinical trial, in a sense, a very small scale for sure. 3 physicians, we kind of send them, we ask them to listen to the dialogue, and we blindly send them the summaries, and we don't tell them which one is generated by human, which one generated by ChatGPT-4, and we ask them which one is better. And the result is quite surprising, that we find that average speaking, physicians actually have 50-50 chance to prefer machine generated notes. And certainly the sample size is not big enough to draw affirmative conclusions, but this experiment really inspired us to pursue further. It also showed potentials of using ChatGPT-like models in some mundane tasks, such as generating clinical notes, things like those. And so really, I want to use the last slide to kind of to call for more or less call for projects. So we have this contest, which we just announced, is called Generative AI Contest, in which we hope to receive proposals from all the physicians, all the doctors in UHN to kind of come up with ideas that we can use either ChatGPT-4 or clinical chemo from our own to help any project that can use things that can improve your daily workflow, or have a better idea, generate medical or biological hypothesis. We welcome to your inputs and comments, and certainly we definitely need your wisdom. So this is really a call for proposal. So if you are interested, feel free to scan the QR code or log into our website, and then you will find most of the information about this call for proposal. And really, we look forward to your brilliant ideas to use generative AI to help advance the current healthcare systems. So that's a quick talk, and I really want to leave more time for discussions, and happy to take any questions.
Thanks, Bo. That was really exciting to hear, and encouraging. I just wonder, I'll start the questions. Anybody, please put your questions in the chat, and we'll be happy to answer them. One of the things, Bo, is how do we handle or interpret the fact that some very high-profile people in the field, including most recently Professor Hinton, have sort of cautioned us about what we do or what's going to happen with AI in our world?
Correct. So yeah, you're right. So even before Professor Jeff Hinton quits Google and called for kind of awareness of a caution of AI risk, there's also a very famous kind of open letters call for 6 months pause of AI research. And it's fascinating that before ChatGPT, nobody talks about the real risk of AGI. People talks about, but many times, many people just kind of laugh about it and saying we are far away from AGI. It's about 50 or even 100 years away. But after ChatGPT, I think that views has greatly changed, and all of a sudden people realize that AI can be a lot smarter than we originally expected. My opinion is that I don't think it's practical to stop AI research right now. And instead of pause for 6 months, I would instead, use these 6 months to put more resource to AI safety research, right? As we already see some early success of AI alignment. There's techniques that can align human values or societal values to the large language models. And I think this research can be further enhanced to really improve the kind of the behavior, the performance of AIs. And yes, that's my comment.
One other question that came into the chat is UHM planning any guidance on which large language models may or may not be okay to use for non-clinical or non-confidential work?
Yeah, that's a good question. So right now, I think even for this call for proposal, we want to constrain ourselves into a research scenario. So it's not for clinical practice, and it's only for research. And there's no PHI involved. And we can also help. We should also apply for REB to get approval first, and really treat it as a rigorous kind of research project.
I think the question more was the non-PHI work. Will we be giving any guidance for that? I mean, that's a broader appeal.
Yeah, so for non-PHI, I think it's much easier to kind of handle data sets. We can use HCP for Health to work on these AI projects. And also part of the functionality of this AI hub is to provide expertise to help physicians and clinicians kind of guide us through the whole AI research pipeline. And I think we can get lots of, I think it's really our joint effort to design such guidelines altogether. And I definitely look forward to working with all of you to kind of design such guidelines and work on some exciting ideas.
Another question was, are there any strategies or methods you can recommend to incorporate more recent data beyond September 2021 into ChatGPT outputs?
That's excellent question. So yeah, so as we know, ChatGPT, I think ChatGPT 3.5 was only trained by the year 2021. That's why some of the information was not up to date. And I believe ChatGPT 4, although it claims that it is still trained upon the the time point of 2021, but from my own experimentation, I found that ChatGPT 4 actually was trained with a lot of new informations. It knows who is the current, U.S. president. Also knows some of very recent information. So I feel like secretly OpenAI already, or even Microsoft, they already kind of fine-tuned with some new information somehow. And to answer your question, the answer is yes. So as long as we can collect our own data, that's also how we train clinical camera. We didn't constrain ourselves to the time point of 2021. We can further collect information. So one of the power from these large language models or generative AI as a whole is its very impressive zero shot of few shot learning. So what is zero shot of few shot learning? It's basically the idea that these large language models trained with massive amount of text. They already know most of things about human language. So what we do, given a new task with very small data sets, what we can do is just fine tuning. We take the base model, we don't train from scratch. We take the base model, we fine tune these large language models using our own data set. This data set can be small, certainly bigger better, but it can be small and then can be very specific to one type of application. For example, you can only train medical information about cancer or about cardiology, things like those. And then we can constrain ourselves into a very narrow but maybe more accurate scenarios. So hopefully that answers your question.
So there are a couple of questions coming in along the lines of, will AI or large language models help us bridge the gap in diagnosing things that we've struggled with, like subclinical things like early lung cancer or early pancreatic cancer? We have failed to detect them early enough before the patient presents. Do you think this gap will be bridged by AI?
I don't know enough about these specific areas you mentioned. However, I do had experience in which we can actually have a predictive model trained from AI from these large language models to have very strong predictive powers for future occurrence or onset of disease. And really the trick is your data set. So if you can give the AI or machine learning models some historical data sets with certain risk factors, for example, or medical imaging or clinical notes, and with some follow-up data sets. And the machine learning will be very good, particularly these large language models will be very good at picking up subtle patterns and build itself a very strong predictive model. So the best answer is it depends, but from previous experience, I'm quite confident that as long as we have good data sets, training data, I'm pretty confident that this large language model can pick up very quickly from the data and have very strong predictive models.
Yeah, but I think in terms of the early diagnosis of cancer, like preclinical cancers, that data set's not there yet.
Yes.
So I don't think AI is going to generate it because it can't find it, right?
So the thing about AI is garbage in, garbage out, right? So it's very heavily dependent on data set. If we don't have such data set, then it's very unlikely that we can have a very strong predictive model. But
Speaking of garbage in, garbage out, I mean, you saw what happened with the COVID vaccines and the information available on the internet. So how does ChatGPT deal with fake or biased information on the internet?
yes, that's part of the reason why so many researchers are concerned about the rapid development of AIs. We already see lots of fake images from deepfake in Twitter, in all the social networks, and also disinformation or misinformation online about vaccines, about many other things. And to be honest, it's very hard to even AI, even like the best AI models having a hard time to distinguishing which one is real, which one is fake. For example, OpenAI released their own detectors. They released ChatGPT. They also released ChatGPT detectors to detect which text is generated by ChatGPT. And the accuracy was pathetically only less than 30%, which means the text generated by these large language models is so realistic, it's very hard to distinguish. So it really depends on the data. Therefore, as I mentioned, I think it's a good time to start thinking about how to regulate these powerful AIs.
It seems like, one of the things about peer review process was, it was viewed as it at least maintains a quality or a door entry. And then the mentality went that peer review became too restrictive and contained people's ideas. But now it almost looks like you need AI peer review to decide what's the hallucination, what's not, what's garbage, what's not. Like, do you think that the machines will get smart enough to do that?
That's a very good question. So um, I I think there's already attempts from these high-profile journals such as Nature Science that they start to use some of these AI tools to help streamline some of the review process, and clearly we are in the not only we're in the healthcare crisis, we're also in a peer review crisis in the sense that reviewers are burned out. There are too many papers. It's very hard to pick the to sort out the real jewel out of all lots of papers. And AI can be used as a screening tool, to be honest, just to say what's the rough quality, how good it is. But at the end of the day, I would still rely on the opinions from experts to really have the final say about the acceptance or rejections, or to provide feedback, things like those. I don't think AI is smart enough or intelligent enough to generate new knowledges, particularly new hypotheses. And sometimes it just simply hallucinates.
There's a question here about auto GPT and what do you foresee may be its biggest benefit in healthcare?
Correct. I haven't seen any application of AutoGPT in healthcare yet. For
Can you
one,
say what it is for the audience? Can you tell us
sure.
what auto GPT
For
is?
others, for others who don't know AutoGPT, AutoGPT is basically an early prototype of so-called AGI in the sense that it can simulate lots of agents. For example, it can simulate lots of large language models, and they can interact with each other by showing the tasks you want. For example, I can say the task I want is to create a personal assistant. And then one large language model will say, is the first step is for me to access your calendar. The other another large language model will say, the second step is know your preference or which day is good for you to meet with others. Things like those, and all the agents will cooperate with each other to even critique each other and further improve each other. So really, the powerful thing about Auto GPT is its ability to train future generation of AI. And it's treated as one of the early prototype of AGI and haven't really showed too many success yet, but it's very promising. I think that's probably one of the next steps of future GPTs. And we haven't seen any application in healthcare yet. For one, is sometimes it's hard to regulate these large language models. For two, is sometimes also it's very hard to design concrete tasks for these agents to operate stepwise. So the answer is no. We haven't seen any potential application yet, but could be useful in the future.
Another question or comment is, do you think that it's already too late to try and regulate LLMs or AI in general? Is the cat out of the bag?
That's definitely a hot take. It's, to be honest, it's probably true that it's already late to regulate because it's almost impractical to put a brake on these big corporations such as Microsoft or OpenAI or Google to say from now on stop research on large language models. I don't think that's practical, and unless we come up with really strong regulations, otherwise AI development will not be stopped. And right now we are really seeing exponential rate of progress in AIs. Even myself, if I don't read the papers in 1 week, I feel myself is obsolete in AI. So the rapid of AI development is just beyond human comprehensions. So that's why it's very timely to start thinking about how to regulate, how to put guardrails about these large language models right now.
I think your comment about that we need to do more research into the safety of AI and how to implement it safely is very important, because in medicine, we learn a lot, and more important than what we learn is we learn how to evaluate new knowledge. Like, how do we is this, how to evaluate it, and is it something you would implement in your practice? Is it something you would do? And the same thing when robots came into surgery, everybody said, oh, you won't need surgeons anymore. It's not true, because robots will kill people. Surgeons driving a robot can do better surgery, right? And we learned, where would a robot fail you in tactile sensation? Where does it fail you in navigation? And where does it help you? So, I think the same thing, we've got to figure that out. Like, where can it help us? And importantly, where is it going to fail us? And that's what I worry about, the general application of it. Like, many of our patients go to Google and they find all kinds of crap and they come and tell you about it. And the question is, if they're going to act on it, and it's wrong, that will harm people.
Correct. So this is also part of the reason we have this AI hub, is to provide educations to all the patient or doctors or nurses so that people are more aware of these AI tools and knows their pro and cons, knows their limitations. And really my favorite quote is that AI will not replace doctors, and doctors who use AI will probably replace those who don't. That's why I think it's really a good timing for us to know more about these powerful AIs and more importantly, think about how we can use these large language models to improve our work, to improve the current workflows, things like those.
Well, that brings us to our time. Thank you, Bo. That was a fascinating lecture, and we'll have more in this series. We had over 180 people listening to you, and obviously there's a lot of interest. And I didn't get to all the questions, but really one of the things that Bo and I will work on is how will we enable AI work in UHN, access to our data and working with the data that we have internally to enable us to do great things with AI. So thank you all for joining today, and we'll see you at the next rounds. Take care.
Listening.
Bye.